In this lesson, we'll be exploring similar triangles. And your learning targets are listed. Take a moment and read them. Similar triangles. Did you ever wonder who invented math and why did they invent the math that you're studying? Well, in this lesson, Similar Triangles, we can thank Thales. Thales was the teacher of Pythagoras. He lived 600 years before Christ, and one day he asked about the height of the Great Pyramid. And they didn't tell him what the height is, so he wanted a way of measuring it himself. He decided to use an indirect measurement approach with similar triangles. And so his method of measuring really tall objects is the basis of what we'll be studying in this lesson. Now, back in the middle grades, you learned about proportions, and this is just a review. A proportion is a math sentence that sets two ratios equal. And you can write equivalent fractions to help you solve for one of the missing values. So we have an example, 2 over 6 equals 10 over some number, 10 over x. And we can see that there's a relationship between the numerators, a multiplicative relationship, 2 times 5 equals 10. And so 6 times 5 would equal x, x would equal 30. So using that similar kind of multiplicative thinking, let's look at the example that's set before us. Do you see a relationship between the numbers in the numerator? Do you see 3 times something equals 12? And so that same relationship would hold true in the denominator. What number times 4 equals 20? We can work backwards and do 20 divided by 4 equals x, so x equals 5. So basically we're saying 3/5, the fraction 3/5 is equal to 12 over 20. Now let's have you try one. We've got the sample problem for you to look at, but this time we're going to introduce and just remind you about something called cross product property, or cross multiplication. And what we have in a proportion is cross products are equal. The numerator of one fraction and the denominator of the other, when you multiply them together, will equal the product of the other numerator and the other denominator. So in the sample problem, we have that 5x equals 180, and then we solve for x by dividing by 5, and we would get that x equals 36. In other words, 5 over 12 equals 15 over 36. Here's the problem we would like you to try. And if cross products are helpful, by all means, go ahead and give it a go. So what we're going to do is we're going to multiply the cross products, 15 times x, and set that equal to 10 times 6. Now we're going to divide both sides by 15, and we get that x is equal to 4. This means that the fraction 10 over 15 is equivalent to 4 over 6. So now that we have two strategies, either equivalent fractions or cross products, let's ask you to solve two examples here on your own. Solve for x in each case. Pause the video, then come back and let's compare. So for this first example, I noticed that 7 times 12 is equal to 84. I just happen to know that multiplication fact. So if that's true, then x would equal 2 times 12, because we have equivalent fractions here. X equals 24. Now in the second example, I don't know 8 times what number equals 12 off the top of my head. Whenever that happens, I typically use cross products. I multiply the cross products and set them equal, because that is a property of proportions. So I'm going to say 12x is equal to 72. Now that's an equation I can solve by dividing both sides by 12. X is equal to 6. Now that we have the background, these are the building blocks that we're going to need to think about similar triangles, let's talk about similar triangles. And in math, it's very important to be precise in our definitions and make sure we're using the correct terminology. Similar triangles are triangles that have congruent corresponding angle measures and proportional corresponding side lengths. So the two triangles we see here in this picture, triangle LMN and QRS, these triangles are similar. One is just a scaled up version of the other. The side lengths are not congruent, they're proportional, but the angle measures, as we can see with these markings, the corresponding angles are congruent. So what we're going to notice, and we'll just make sense of this word proportional side lengths, is if I write a ratio of corresponding sides, side NM corresponds to side SR. So the fraction would be 8/6. ML corresponds to RQ, 12/9, and LN corresponds to QS, 4/3. We're going to notice that all three of these ratios all equal 4/3. If I simplified the other two fractions, I'd get 4/3. Because the corresponding sides are all proportional, we know the triangles are similar. We also see that the corresponding angle measures are congruent. So we can write what's called a similarity statement that looks like this. Triangle NML, notice the order of my letters, starting at angle N, working toward angle M, ending at angle L, is similar to, notice that little tilde, that means similar, triangle SRQ.